Gabby, you see X. Oh, no.
Yeah. I literally got y equals x minus 1.
Okay.
Once you have yours ready. Once you have a solution to theirs ready. With them when they're done with theirs.
The square root of 4x squared minus 4.
Wow, why? Why did
What did you
how do you get 1 half?
C y equals
CX?
Okay, yeah, I got that right.
Isn't it, you only
I got
bring
you
it
here.
down, okay, you only bring it
I
down.
didn't do that. See, I solved for y.
Oh,
And then I put
well.
For yours, I got y. Plug in 0.
I didn't.
Negative.
Oh wait, I did. I was looking at your.
Plus or minus.
You have to get rid of 1 half.
Well, give me the hard one. You want a hard one?
You're the one that I'm doing. Okay, yeah, you get 4 and C sharp.
Am I good?
Yeah, you're
Yeah.
So I can get
No.
right this time.
No. You can only bring it.
You're on the right track, Gabby.
Why? Wait, so you can only bring down C as
You're on the right track.
For yours, I
in
got
front of the variable. It's to the power of, not if it's adding. Is it? Let's see. I love how Kyle explains. Just take the equals. Like everything's really easy. I love that.
What's Kyle's?
So if it, I'm adding this one.
What?
This is you'll go through emotional trauma. Like,
That looks fun. Not
You guys are still working.
you want to see mine?
Alright. Who's checked already and you agree with what their solution said? Alright,
Gabby
1,
agreed with
2.
mine.
Yeah.
But Gabby's focused.
Double check. The original creator might have been wrong, or the solver might have been wrong.
Gabby's in the zone. You can bring this down if it's added.
Back in the zone.
I thought it was if it was the power.
X squared plus C.
That's what you did.
Alright.
No, not to the power. No.
Except you can bring this power up, remember? Oh, wait, why do you have a 7x?
Because it's a 7.
You're thinking about
1 over 7. So you can take the 1 7 ln of x.
Okay, talk it out with them because you made it for them. You have a solution to it. Check it.
Yeah.
Did they catch a mistake of yours? Did you catch a mistake of theirs? How many of you are still stuck?
So 1 7 ln of x, so then that means I would. Are stuck. Then this crosses out, so we just get x to the 1 7.
Let me see if you guys match that.
Let's see.
Why did you make us?
This one?
No, not plug in your.
I can't check your answers because I didn't finish with it. I'm gonna finish it. 1 7. No, I'm not. Isn't that just 1? Got it. What do you mean, what did I do? Never mind. I did is I actually factored it out and did it 1 by 1. Oh, sure.
It does equal 2. Now plug that one.
You did like a weird case.
Yeah, you can do
Easy.
Oh, you did use those.
that. 0.
Yeah, you forgot that existed.
Give it to you.
Oh, this one.
Well, I know you did one. Oh, you did it?
C is 3. No, you sure? Y prime equals ln of x over x over
Like, so not cool.
everything times
But you didn't give an initial condition.
parentheses y minus 1 half.
It's magic.
Okay, what's the one you solved?
See how you wrote down.
That felt too.
I wrote the one you gave me. You didn't
You're the one who wanted it.
Contact
You're the one who wanted it.
touch it.
Yeah, you're like the one who's all.
Yeah, but I can't touch you. I can't touch it.
So does this make you uncomfortable?
Very much so. You know what I used to do in AP Bio? I used to put my, like, he would have his nose,
I thought.
and then I'd be like,
I would just tolerate it.
I mean, I think I was pretty nice.
No, every once in a while I'll do it. Other times I'd be like.
I thought that someone had to see by the 6.
Just like that. It was either Eileen or Scott. Yeah,
When you plug it in, like 3 hours. Alright, who thinks?
don't feel bad, but I always.
Let's see.
Okay, here, you can have it.
Who thinks that they received, they had to solve a pretty good, pretty tricky, you're like, I'm impressed with the difficulty. Kyle, that was given. Alright, let's see.
She had a pretty tough one that she had solved.
But I mean, like, you're impressed with how difficult they were able to make it while still being solved.
Oh.
Okay.
Mine was
Yeah, I know, yours is too. I revoke my
just
hand.
creative.
Oh, just creative?
It wasn't.
Let me see both. Okay, Katrina, what problem did you get?
Y prime equals ln x divided by 2. I'm sorry, divided by x squared. Times parentheses y minus 1/2.
Y'all went full.
Steve, I don't think this was solvable. No, I do not like you. I see exactly what I have to do. Steve, you mine is easy.
Oh, is it?
After 2.
Alright.
Yeah, it was.
So for those of you guys that maybe didn't receive one, he's in here, it was for you. Or didn't make one. Okay, let's all work on this one together and we'll see whether the one that Noah made for Katrina makes sense. Okay, question, work together. One last one in our workspace, see if we can all do it. I wanted to see how tricky we could get. So here we go.
I don't have space.
You want to divide by 1 minus
Oh, I messed up.
and multiply by dx.
And multiply by dx.
Yep.
I didn't do 1 over.
What was the initial condition, Noah?
Oh, I didn't give one.
Never mind.
He didn't think we made it.
That would be kind of neat.
That would be.
Alright, so when you solve, we have to integrate both sides, right?
Yep.
Yeah, we can make u y equals, so we have ln
Wait,
of.
can you put 2 units for both sides? Are you allowed to do that?
Yeah, because it'd be a u and then like a v, or you can think a u for this integral, a u for that integral. A u's not necessarily enough for that one, I don't think.
Integration by parts.
Yeah. What would you make your u for integration by parts?
ln x.
X.
Liate, get rid of that ln, right?
Yeah.
Okay, now pause. Let me give you 60 seconds to get ahead. I'm just doing it now. We got it started.
I'll get a great teacher.
No, I think that's
Hey guys. So maybe you're still explaining how to do your problem to someone, or you guys are collaborating with how you thought and how they thought, and who's right, who's wrong. A couple of you are still trying to finish your problem, but we're all working on this one now, so let's go ahead. If you're still finishing, go ahead and finish, that's okay, but for the rest of us who have already finished, we're tackling this problem with Katrina who's trying to finish it from now.
I'm sorry. Is it plus or minus? For integration by parts. It's 1 over x squared. It's x to the negative 2. Wait, what?
Yeah, it is.
Ooh, 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 ooh.
Thank you.
Whoa. Slow down. There's nothing doing bad with it,
I'm sure you got it right now. I did something wrong.
Wait, Kyle solved this one too.
No, he wants to solve it.
I never fell asleep in my class. Steve,
Yeah.
have you ever done U sub before this? And then canceled out one of the x's? Would that work?
Yes, I did.
Oh,
I didn't go
I
back.
integrated badly.
It would have been go to e to the x. Because you would have had another x, and so you would have had to do integration on crack. And so solving would have been e to the x.
Wait, so is there like an actual word for
I don't think it would have been possible without integration.
crystal math?
I'm telling you, very.
Please put on this one. Come to my head, I have crystal math.
Why so good?
So if you do it has to be an actual, like, the fact.
Oh, wait, did you take it?
How to be able to be multiplied by that to make the integral,
It's
right?
UD. It's VD.
I really don't like you know.
Oh, never mind. It's not hard. Wait, what?
Because I thought the UV was like just choose
Wherever it's take whatever's left, you have to make sure that if u is 1, then dv is the rest.
Yeah, I thought that it was like how you do use of like you can choose wherever you want it to be, but so we're reading how it was like inside of it, not what it actually is. So like if you choose like an x squared on the bottom.
Oh, you still have to make it 1 over x
Yeah.
squared. Yeah, Corey caught that. I was starting to go that way.
I mean, integral, that's 1
What? Okay, so then I messed up
Hold on, you guys double check me. What do you think so far?
Kyle thinks you're right. That's right.
Kyle and Jason agree. A few others are still processing.
I agree. Illegal.
Why is it? Oh, never mind.
She's accusing me of something I did not do.
Misty,
Then
would
you
you
make
get the
e to
negative
the
on the outside? Okay, hold on.
And you leave
Oh, never mind, just don't have it. You got it.
Wait, Misty, wouldn't it all be on the inside negative? Oh, wait, never mind.
Because it's x to the negative 2, so plus 1, negative 1 divided by negative.
So you have to ln, right? You can tell negative 1 over x, right? Is that legal?
You could take out a negative 1 over x if you really wanted to.
Wait, are you not allowed to split it up, like, to e to the negative ln x over x divided by e to the 1 over x?
Well, hold on, you have to think about exponent rules, right? So exponent rules, if I have subtraction, I can't make it e to this guy divided by e to that guy. I'm not really sure if that helps anything, though. Because I still can't split up this division, so I can't get to the ln with the
Stick
e.
it to the man.
Well, that's what I did.
And then you just add 1/2.
So I just went ahead and separated the e to the c, because that could be the constant. Technically, to get rid of the absolute value, we say plus or minus. So we could say plus or minus. We could call that like c1, if we wanted.
Would that be applicable to like any solution?
Yeah. But what we do when we put the plus or minus for the c1 is we make it a c2. So we just make it a new arbitrary constant. That's what we've been doing anyway. So we could just say plus a new arbitrary constant c2. So no initial condition, huh?
Nice job, Noah.
It is solvable.
You were supposed to solve it and know that.
No, we didn't fail.
That's what you should just keep in mind. Y prime is equal to x over y.
If you were to do an initial condition, I would probably use when x equals 1 just to make it easy, because ln of 1 is 0. And that'd be 1 times negative 1.
But then,
And then you can go ahead and make it,
1 over e.
oh gosh,
1 over e.
yeah, it'd be 1 over e. So we can make that like
That's not recyclable.
3/2 minus 1/2 would be 1. Yeah, you could have made it like 1. I would have said for the point x equals 1 and y equals 3/2. Do you guys see why I did the initial condition of 1 and 3/2?
Yep.
Because then when you go ahead and plug in, I would have 3/2 equals 1/2 plus c e to the ln of 1 is 0 plus 1 is 1 times 1 over, that'd just be negative 1. So I'd subtract the 1/2 c over e. So e equals c. That would have been a nice one. That wouldn't have been too
Nice
bad.
job, Noah.
You should give this to your Amy class.
When I get there?
Yeah.
But they don't know how to do integration by parts.
And so you just tell me, just tell me the way to solve it.
no, just let them try to figure it out.
When they learn it at the end of the year. Yeah.
We never learned integration as parts.
We watched the monkey seven.
Oh, yes, we
There
did.
was the extra credit assignment.
Extra credit?
Last
Yeah, like
year,
we said after the EP.
Like at the very
From
end.
Stand and Deliver.
Very end of calc.
Yeah, only if you did.
And then we went back for sure.
Okay, nicely done. Some of you guys were able to. Some of you guys were able to take full advantage of this activity. A few of you guys kind of wasted it. But hopefully it was kind of fun just to think of, could I make up my own differential equation, solve it with an answer, and give it to someone else and see how they do on it, and instruct them to the answer. Okay, let's go ahead and finish up our exponential growth and decay, section 7.4. Homework due tomorrow. Corrections due by the end of the day. On to chapter 6 test. Any questions about logistics? Gabby?
Can we take notes in pen?
It's up to you. If I make a mistake, or if I change something, don't get mad if you're doing it.
Okay. We'll get mad, but not truly. We'll just be frustrated at ourselves.
Everything.
Alright. Okay, let's go ahead and practice a procedure that technically should be in place, and yet for some of it it's not. Once we start as an entire class focusing on a certain task, whether it's a workspace problem, whether it's in the notes, all the extra conversations need to cease. Start practicing that procedure, just to help our class be efficient. Application, exponential growth and decay. Exponential growth and decay comes from a rate that is directly proportional to an amount. a rate of change of a certain quantity directly proportional to the actual amount of the quantity. So as the quantity goes up, the rate goes up. As the quantity goes down, the rate goes down. Could be directly proportional, could be inversely proportional. Not inversely proportional, that wouldn't make sense. That'd be squared. Inversely proportional, that is possible, but that would not be an exponential growth. So exponential growth and decay comes specifically from directly proportional. And we know that just from our experience in solving by separable differential equations, because every time we have a constant times any quantity, we're always going to end up with an ln. And to undo the ln, we're always going to do an e. When we undo the e and use exponent properties, we're always going to have c times e to the kt, which could be, in a sense, is the general equation for exponential growth. Now, once again, is all growth exponential? And the answer is no. If it's some sort of growing word problem and they give you some other differential equation besides ky, you're not going to have exponential growth. So that's why we don't really memorize exponential growth. It's just more something that naturally occurs out of an integral if you have an initial condition. But there are definitely things that we could memorize, like doubling, half-life with different populations or radioactive decay. We could memorize stuff, but since not all growth occurs exponentially, Corey, put your hand down. Since not all growth happens exponentially, then we have to be ready for using those different keywords like doubling or tripling or half-life in other situations and other types of growth rates as well. Okay? So, let's get into just a couple of these word problems, hopefully getting them both done before the end of class. I think we have three. We have three. So technically, kiddos, yes, the book gives a theorem. Yes, there is like a nice little oh, look, it's a general growth equation, where we could talk about things like how y is going to be the amount after time t, where c is going to be the initial condition, because when t equals 0, you're just going to have c left. We could talk about how k is the rate. So maybe in a different calc class, they might go through all these different things, and you guys actually memorize, like, oh, hey, for a double, when you have an element or a population that's doubling, you can always make k equal to ln of 2. Well, that's great and all, but what if it's not exponential growth? I don't want you guys to get stuck in one model when they might give you another one on the AP. Long story short, whenever the k is positive, we're growing. Whenever the k is negative, we're decaying. So, do you need to memorize this? I don't think so. I don't think you need to memorize it. Can you write it down? I suppose. Can you look at the theorem if you get stuck on some? Sure, but long story short, it comes straight out of a differential equation anyway. So, what are we going to do when they say the following? Rate of change of y. Good. Let's translate. What does that mean?
dy dt.
Good. dy dt is equals proportional to k times
Y.
y. Now, we just solved this, didn't we? Yeah. Okay, so sometimes you can make a jump only if the differential equation is equal to just a constant times the original quantity or the quantity that we're measuring, whose rate we have. So we can go ahead and jump to y equals c times e to the kt. How are we going to use it, though?
Oh, good.
Yeah, we can plug in our initial condition when t equals 0. So we can go ahead and say when t equals 0, y equals 2. But what's the dilemma?
No, you just solve for c.
Oh, nice. But what if t equaled 1? Would we have a dilemma?
Yeah.
Because we'd have two unknowns. Just keep an eye open. You might have to do some pre-calc, some algebra 2, using two equations with two unknowns. But you're right. From this, we do end up with c is equal to?
2.
Just 2. Anything to the 0 power is 1. C is equal to 2. So why on earth do they give us a second point?
To find k.
Oh, because the whole point is to use this equation, and I can't until I have C and K. So we can go ahead and say, all right, so then Y is 4 when, well, we know C, right? Okay, so let's plug in. We don't know K, but we do know T is equal to 2. Throw in an ln to get rid of the E. Divide by 2, we have K is equal to 1/2. How else could that appear?
ln square root of 2.
Yeah, we'll do or. ln of root 2. Both ways work. And now that we have C and 2, what can we go ahead and do? Yeah. Y of 3 is equal to, let's take our C, we have our E, we know our K is ln of root 2, and now our T is 3.
Would the E and the ln cancel, or no, because it's T squared, it's not.
Can you guys help out with that? Log property, since we have a lot of logs in these?
Yes.
Can I cancel out the E and the ln?
Yeah.
Let me rewrite it and let me have you try to answer your own question. Can we cancel them out?
Now you can. No.
But if you were to cube it,
You could separate them. Now you can.
If I use the power property of logarithms, now I can cancel out. So I'd do the same thing as 2. Well, wait a minute, hold on. Can't I simplify the square root of 2 cubed?
you're 3 halves.
I can make it 2 to the 3 halves,
Wouldn't be 2.
or 2 to the 1.5. Or wouldn't that be the same thing as 4 root 2?
Yeah.
Could you say 2 to the 1 times 2 to the 3 halves? Which would be 2 to the 5 halves, right? Which is 2 to the 2 and 1/2. Which is 2 to the 2 times 2 to the 1/2. 4 and square root of 2. That's one way. That's one way. But either way. Fun, 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 fun. Man, I had a lot of like algebra stuff. Not really a lot of calculus stuff, but a lot of algebra stuff. Just watch out. Some of you would have been stuck back here with ln's and 1/2s and 3's, and who knows how that would have simplified. Word problem number 1, check. Word problem number 2.
Wait, wouldn't the answer be 8?
I don't think
Never
so.
mind, it's 4.
Okay.
Ignore me.
Oh, so that's square root. Alright, this is exciting. The rate of decomposition of radioactive radium is proportional to the amount present at any time. The half-life of radioactive radium is 1,599 years. What percent of a present amount will remain after 50 years? Mathematically, how do we think through this without memorizing all sorts of extra formulas with half-life and doubling and that?
Do ideas.
This directly proportional, what can we use?
That. This needs to be a negative, right? Does it?
You could put a negative up there to symbolize decay, or your k should end up being a negative number. Either way works. But you could throw a negative in the k saying, oh hey, it's directly proportional, but I'm decaying, so you could throw a negative in, or it'll naturally occur if you do it right. But they don't give me an initial amount. So what do I do?
Oh, if the half-life is 1,599, wouldn't it be double that? It's like the original one?
No, half. No, that's original half of that.
What did I just do? Oh,
I took how much I have after t over how much I started with, and guys, what's that going to be if it's called a half-life?
1.
I don't know exactly where I started or where I'm ending, but I know the ratio is going to be a half. Does that make sense? And the ratio is going to be a half when time is 1,599 years. You don't always need to know everything. If you know the ratio 1/2, you can say, oh, okay, let's take how much I have, how much I started with. Cool, it's going to be 1/2 when I divide. Whether it was starting with 500, now it's 250. Whether it was starting with 3.7 and having now 1. What would it be, 85? So now all I have to do is, take a log. I'll take an ln. I wouldn't do a log. So I do have k is equal to negative 1 over 1,599. Now guys, this is a formula if we were talking in some like physical science class or in some other application. They might have you memorize for half-life. It's always going to be, or k is always going to equal negative 1 over the half-life times ln of 1/2, or another way of looking at it, this might be a little bit nicer. Couldn't we say this is 1 over 1,599 times ln of 2? Cool. How'd that happen?
Oh, because the negative went up.
The negative could come up as a power. And what's 1/2 to the negative 1? 2. Either way you look at it, it's going to be the exact same decimal. That's k. But what were we supposed to do with it?
What percent?
Yeah, what percent? How do you get a percent? Isn't that like a fraction? What do we have?
Fraction.
We already have a ratio ready to go. And once we find the fraction, can we make it a percent? So let's go ahead and say what percent of a present amount will remain after 50 years. So I can say, let's figure out the ratio that will be left when I plug in after, ln what, ln 2? We can get rid of the negative again if you want.
Well, no, it's element 2, so you got rid of the negative. Oh, because it's over the
Yeah, I think there's another one, just because we had the negative present. But you're right, it will end up being 1/2. Yeah, plug and chug. I need a calculator. You guys have one, folks? Because once we get the decimal, all we have to do is go ahead and change it to a percent, right? I'm actually not sure what my calculator is. Someone borrowed it yesterday, and hopefully it comes back. Did we borrow my calculator currently? Not I. 97.856?
No, it's point.
I got 0.97.
Oh, that's the percent you multiply by 100?
Oh, no, I have multiple.
Ah, percent.
It's a percentage. Yeah, you get the decimal, then you multiply by
97 point, yeah.
Because that's just the ratio, so we have to go ahead and just change it into a percentage. Does that make sense? Times 100, multiply or move the decimal 2 places to the right.
You said C equal 1.
No. The ratio itself,
Okay.
the ratio itself is what we're solving for. So what's the ratio that we have, and once we have that, we go ahead and move the percentage. Does that make sense? Because if it was a half, we'd say, oh, we have 50%. If it was a fourth, okay, we have 25%. But the ratio was 0.97855, etc.
Yeah.
So then our percent is 97.
Okay. I was thinking of the fifth one.
8.6%.
Yeah, I just made
Okay. So I guess you could say after 50 years, if C was 1, you have 0.97855.
yeah.
Without knowing C, you can think of it 2 different ways. Alright, cool kids. However, what just changed as soon as I changed the page?
There's a delta T pretty much.
It's like a delta T. Do I still have directly proportional to?
Yeah.
Yeah, but to what?
I mean, you're getting the rate of rates. Rate of rates. Rate of the
Now the crazy thing is I don't want you guys to memorize Newton's law of cooling. That's not the point. But the point instead is that if we do know how the rate is defined, we could go ahead and figure out how their original quantities are related. Does that make sense? So we could go from the rate backwards to the relationship by integration. So technically it will still be an exponential model, But obviously, it's not going to be quite as clear cut as y equals c times e. But if you guys look at it, doesn't it look pretty similar though? Yeah. If you were to think about this as a variable, well, that could be like a y, right?
Yeah.
So if that was my y with my capital T, I could go ahead and divide. I would have ln of, which I would do e to the power of both sides. This is what would remain. This is my y, so that could be my y. So there might be ways of solving this to make it a little bit more like a normal exponential growth model.
Start calling. What's T0?
T0 would be the initial. TS isn't that the temperature in the room? Because you have the initial temperature of an object, and then you have the actual temperature in the room. Not the S temperature.
This is actually
Surrounding?
It's like actually the potato question.
It's pretty close to surrounding.
So it's about the internal temperature being this and the outside core.
But they didn't make you like use or memorize actual Newton's law. They gave you a formula or a differential equation that you were able to solve that wasn't near as complicated as how this is being written. This is basically saying delta T in a sense, or you're saying the temperature that it currently is minus the surrounding temperature. I'm going to use S for surrounding. Actually, I don't remember what it's called. And then T sub 0 be the initial. So how can we plug in though, guys, if we did have the top line density? We know where it starts, right?
Yes.
Who's that?
Initial.
No.
T sub naught.
T sub naught would be 100 degrees. That's the initial temperature of the object. What else do we know?
Final.
Final temperature, which would be like just the normal T.
Oh.
Or you could say, if you want, you could say T of 10 minutes is equal to 90 degrees. But that would just be like the normal T. What's the surrounding temperature? What's the... So T sub S would be 60 degrees. So how can we use all that? Can't we plug and check? Okay, so what would be the change in our, where we are now from where we were, no, from the room temperature?
90. Oh, 60 to 100.
Where we are now.
60.
So 90 minus 60.
Equals 100 minus 60.
TS is 60.
Oh, it was me. I thought you guys said 100 minus 90.
I said that.
And then how long did that take?
Minutes.
Did you say minutes or seconds?
Minutes. I said seconds, but it's minutes.
What can you solve for?
Okay.
And once you solve for K, how are we going to use that to figure out how much longer it'll take for its temperature to decrease to 80?
34 is then your ln plus
So then you make T. You make regular T 80.
You could make T 80, but are you going to still use your T sub not to be 100?
Yeah.
How much longer?
Oh,
Depends
no.
on how you read it. You could make your initial still be 100 and then take that time and then subtract the 10 minutes. Or couldn't you make your initial temperature be 90 now?
Yeah.
You could do it that way as well. So you could solve, get K equals. Then once you have your K, you could go ahead and either use your initial as 100 or use your initial as 90. And one will be solving for the outright answer, the other will be solving for the entire time from the beginning of the model. Now kids, I'm quickly going to look, because I just thought of a different answer, or I should say a different interpretation of S and O. That would totally switch what we just made it. Hold on. You guys can look at this. No, we did it right. Alright, well kids, that's the end of section 7.4. It's mostly applications, and it's mostly a specific type. So it shouldn't be bad. Let's see how many questions you have tomorrow. Bye guys, corrections due by the end of the day. Alright, sounds good.